Hi, everyone, and welcome to the EPICS and IEEE virtual event, Creating Impactful Community Service Learning Projects. A few housekeeping items before we get started. The session today will be recorded for later viewing, and the slides will be made available to you after today's session. During the presentation today, please post any questions for the speakers into the chat to the right of the event window. We'll have a few minutes at the end to take a few questions. And now I'll turn it over to Pedro Whiteman, the EPICS and IEEE Committee Chair, to kick us off. Thank you.
Good morning, everyone. I am Pedro Whiteman. I am the chair of the EPICS and IEEE Committee, and I welcome you to this panel, Creating Impactful Community Service Learning Projects. So I'm going to talk a little bit about the EPICS program. Well, also introducing then our panelists today. We have Jeff Katz and Kai Goodall, who are committee members of the EPICS and IEEE Committee. And also we have three project leaders that have participated in this program. Joseph Kosev, Anagya Das, and Nubila Husna. They're going to be talking today about how their projects became so successful, and which were the challenges and how they solved those in the process of creating the proposal. Next, please. So what's EPICS in IEEE? So EPICS stands for Engineering Project in Community Service. So this is a program under the Education Activities Board of IEEE that support service learning projects that advance technology and benefit humanity through funding, resources, and mentorship. So we give funds to projects led by students, by college students, in order to solve a problem of a community hand in hand with an NGO or a nonprofit organization. The idea is that they take all the knowledge that they have acquired during their education and put it into service of the community to solve that problem in a sustainable way, in a sustainable manner that will last for a few years. So this was inspired by the EPICS model at Purdue University. So the four main pillars, so the four main type of project that we look for are must be directed towards education and the promotion of STEM careers and STEM education, access and accessibility. That's related to working with communities with any type of disabilities. We're also looking for environment-oriented projects, either for renewable energy generation or sanitation or elements like this, or human services, which impact directly on the community in aspects like housing or security or aspects like this. So these are the four main type of project that we're looking for. Next, please. So this is a program that has been on for 16 years already. We have funded more than $1.5 million to 255 projects. Just last year, we funded 39 projects on a total funding of $236,000, benefiting 907 students who participated directly in the development of this project. So we're having an impact, a direct impact on the next generation of engineers that soon will become professionals, so we can develop all these nice skills of more than just technical skills, but communication, leadership, and so on. Next, please. So today we have our three panelists, but I'm gonna give them the opportunity to introduce themselves, and please discuss about your project, of course, and discuss which are the most difficult or challenging parts of the EPICS in IEEE application process and how your team handled it. So, Joseph, if you can get started.
Okay, thank you. Um, my name is pronounced Joseph. I'm from the Faculty of Electrical Engineering and Information Technologies at the University San Cyril and Methodius in Skopje. And I teach analog design, embedded systems, sensors, conditioners, and acquisition devices, and also microelectronic technologies. This problem, the project is named What We Breathe. And this problem, what we breathe, persists for years in Skopje, in North Macedonia. So I and my students started to work on this problem even in 2017. And we had one quality measurement device, which was experimental one and didn't last very long. Later, we tried to develop a device for a company, but the pandemic started and it also died out in a way. And anyway, the problem persists, and the idea to help people to know what is the pollution, especially the PM particles, persists. So then I don't know, I don't remember how, learned about the EPICS in IEEE, and I asked the students, would you like to apply for such a project? They were hesitating because they already had some activities. But I said, even if we have it, we will start next year. So they agreed. And finally, we prepared the project. And during the preparation, we had some vague definition of our users. Actually, those should be the schools in vicinity of the faculty, but I didn't have a specification, and their IPEX in IEEE helped me. They asked, can you specify schools and get written consent of those schools that I will participate? So I called some friends. Those are the schools we cooperate with, and they agreed to participate in the project as a basis for implementation. And this part was a little bit challenging to get agreements from the schools, but we did it all right. But the main important thing is to be persistent. If you have a good idea and you have where to offer it, then do it. So that would be approximately our start with the project.
Thank you very much, Joseph.
Welcome.
Nabila, let us know which were the biggest challenges during the application process.
Okay, thank you, Pedro. So hello everyone, my name is Nabila. Okay, so I am from Universitas Multimedia Nusantara from Indonesia, and I am the team leader of an EPICS in IEEE Projects 2024 environmental project that focus on developing an IoT-powered smart agriculture system for pest forecasting and management, specifically for snake fruit farming. So snake fruit or salak is a unique fruit native of Indonesia, and it's an important source of income of some farmers. But farmers here are struggling, especially with pest infestation like fruit flies and unpredictable weather caused by climate change. So to help them, we create my Salak Smart Farming app, which combine IoT sensors to get the real-time data from the field, along with AI features that help to predict the weather, automatically confront fly, and support better pest management decision. So for our team, the most challenging part was making sure that everything we wrote was clear and easy to understand. And so the community could really see how our idea would meet the farmers' need and solve their problems. We first had to clearly define how the system would be developed for the community, what technical components were needed, and how the development and testing would be done, and how it would solve the real problems. And how we solve it is by dividing responsibility among our team members based on their strength. And once everyone complete their part, we brought everything together. And as the team leader, I went through all the full proposal from start to finish to make sure it was well structured and that the solution we proposed to realign with the problem we set out to solve. And most importantly, we have to make sure that the entire plan was achievable within the project timeline. So yeah, that's all from me.
Thank you much, Nabila. Anarchia.
Yeah. Hi, Pedro. So, hello everyone. My name is Anarghya. I am a PhD student in University at Buffalo. So, when we first applied for this EPICS funding, my current research topic was around brain-computer interfaces and using the brain signal in devices which can be wearable and non-invasive. That means we don't want to perform any surgeries to get those brain recordings from your brain, but we want to use those brain signals directly from your brain via non-invasive sensors placed around your head, and then use it in wearable devices like we have smartwatches and other devices that we use for smart health. So our lab was focusing on that, and that was my research area. And then we thought of an idea of helping people with speech impairment, especially older adults who can't communicate properly or talk to their loved ones or use things around their home to like the Alexas or your smart devices. When they can't speak properly, these devices can't hear them properly and do the commands that they want to execute. So that was the main idea of this proposal, where we wanted to fuse their EEG signals with their slurred speech or impaired speech to make them more understandable and make them interact with their loved ones and surroundings even better. So that was the summary of our project, and it had a lot of moving parts. One of them was the software that we used AI, created different models to get the data. And then the other important part was the hardware component, making a small device that is roughly a size of a small coin that could be worn around your head, and it takes in the signals from your brain and then uses that AI that we developed in the first stage, onboarded on that device, and combining the whole thing together to give you an output of what they're trying to say. So it was a project with a lot of moving parts, and especially during the application process, once we proposed this to EPICS, they were very responsive, and they gave us a lot of good suggestions. One of the suggestions was to submit an IRB, which is like an institutional review board, which every university has, because we were dealing with participants who are human subjects. So we had to make sure we had all the systems in place so that their data and privacy were in check and there is no harm to their health. So that was a lengthy process of submitting that IRB and getting that approval and then finalizing the funding. So I feel that was one of the most challenging parts during the application process, even before we started working on the whole project. So I feel, yeah, that is one of the things the potential projects can apply for. And then if you have a grant application with IRB and all the details, then I'm pretty sure you'll have a good chance of getting the funding. Thank you.
Wow, thank you very much to all our three panelists. I think these are great examples of the type of project that EPICS is more than glad to receive and fund because of the impact that they're having. So right now, I'm gonna turn it over to committee member Kay Goodall to continue with the panel. So Kay, you're welcome.
Hi everyone, my name is Kai Goodall. I'm from Cape Town, South Africa, so at the bottom of Africa. And I did a Bachelor of Science in Mechatronics Engineering. I've recently completed my Master's in Electrical Engineering at the University of Cape Town. I have a passion for service learning, and I was the STEM outreach lead for my university in the Electrical Engineering department. And we did a number of outreach events to local underprivileged high schools to teach them about engineering. As well as this then led me to joining EPICS and IEEE, and this is my third year being a committee member. I'm also a co-founder of a deep tech startup working in the telecom space, and I work as an AI and computer vision engineer at a sports analytics company. I would like to just tell you quickly why I think the community partner is so important to EPICS project, and this is because Firstly, it allows you to speak to the community partner and know if your solution will actually benefit the community that you're targeting, as well as your community partner helps sustain the project. So this is very important that before you start your project, you find this community partner so that in your proposal, you clearly state how they will help sustain the project going forward. As well as service learning allows one to give back to your communities by solving their problems, as well as allows one to practice practical skills that you wouldn't always be taught at university, as well as it allows you to develop a number of soft skills. So I'd like to move over to asking some questions. So next slide, please. Awesome. So Nabila, can you talk a bit about how you approach your community partner about getting involved? Thank you.
Okay, thank you, Kai. So, in our team, when we start, we first show up to listen because we thought that we couldn't just show up with a ready idea and expect the community to go along with it. So the first time we do is we visit the snake fruit farmers, had a conversation with the farmers, and a simple question like, "What's been hard lately?" or "What would make your work easier?" And then, for us, those conversations had a big influence on the direction we took because the solution we originally worked in the proposal actually evolved after many conversations with the farmers, because we realized some of our assumption didn't match the real needs, and our solution started to evolve based on their input, and we continue checking in with them, asking for feedback along the way. And later, they were just not giving a suggestion, but they also became part of our team. They help us to collect the data and always give feedback of what we did. And in the end of the project, we also conduct a survey with the farmers to gather their feedback. We wanted to know what worked with them and what could be improved. The response really helped us to reflect on impact of our work, and it gave us idea on how to improve the system moving forward. So for us, the most important part was building a strong, respectful relationship with the community, because in the end, the relationship is just as important as the technology itself. Yeah, that's for me, Kai.
Great, thank you. The next slide, please. Great. Joseph, I'd like to ask you, how did you approach the schools you're working with, and how does your future relationship look with them? Thank you.
Well, the first idea was to visit the neighborhood schools and make agreements with them. But it was not very fast. I mean, they didn't respond to good. And then actually, I called the friends, and they call it. We have schools we cooperate with. It is the competition technology for you that we organize every year, and it will be soon in April. So all these schools responded, almost all, and accepted to participate in the project, as I said, as a implementation, in the implementation phase. And so then it came the development and production phase. We didn't cooperate with them in that phase, but then the implementation phase, of course, we had to define where to position the devices, how will they be used, and how the students will be informed regarding those devices. So we prepared posters, they placed the posters in the schools to inform the students and ask them to participate in a questionnaire regarding their knowledge about the air pollution and the PM particles. So, we made a mistake with the link, and we were surprised we didn't have many students, but later we corrected it. And then within 2 weeks or 3 weeks, more than 600 students took part in this questionnaire. Now, I will meet with some representatives and students from these schools this month. We will talk about it. We will exchange impressions, ideas, how to improve the system. And Some of the students, high school students, will be also invited to participate in the project. Maybe we will develop a new version, an improved version. That is an ongoing process. Anyway, thank you.
Great, thank you. Next slide, please. Great. So, Anaga, I'd like to ask you, can you discuss how you learned about EPICS and how this project has supported your research, as well as how did you utilize your university resources in this project? Thank you.
Yeah, thank you for your question, Kyle. But yeah, so initially when I first learned about this project was actually from a faculty member in our CSE department at UB. So she's the one who sent the flyer to us, and we were like, this looks like a great opportunity to showcase our project and work on what we were building towards. So that's how I initially got to know about EPICS and IEEE. And then after that, the next phases of working started, and then I feel a lot of the help and support that I got for this project was from my advisor and the university resources that he connected to, because one of the one of the challenges were to like meet and interact with the community members. So we have a special division at UB who reaches out to community members and gathers interested participants who are willing to contribute the time and effort for this project to collect some data and test the iterations. And that was very helpful for me personally, getting those people who are interested in this project and willing to help out to further improve the accuracy and detection of this model that we worked on, and try out the devices and give us some feedback on how the device looks and what improvement we can do. So yeah, I feel overall it was a great experience working on this project, but there was also a lot of different challenges. As you can see, that we had gone through different types of prototyping, and finally we finished the device in like the fourth prototype, and there was a lot of hardware difficulties and managing between the teams. And we also conducted special sessions with speech language pathologists. They helped us gain more insights on how speech related impairments work and how people suffer with them, and what we can do in a neurological sense to gather those data more efficiently to make our devices run better and focus towards the final goal.
Great, thank you. I'll just give some closing remarks now. So I just want to say how I integrated service learning into my master's project. So for my master's project, I built a unmanned self-driving solar car, and I built it with education in mind. So I built it to be an educational platform that we could take to a number of underprivileged high schools in Cape Town, South Africa. So we took the vehicle to these schools, and we allowed the learners to interact with it, drive the vehicle, as well as we took smaller robotics kits and built different aspects of the car with the learners. And we did these at a number of different events, and it was great to really inspire the learners so one day they could also study engineering. And I just want to also give some quick suggestions on your EPICS application. So as I mentioned before, please focus on the community partners. I'm sure you've heard today how important it is to really, you can think of ideas with them, you can see how you can help them, as well as how they can sustain the project, as well as focus on the engineering design, to make sure that you've clearly stated how you're going to do the project, as well as how the project's innovative, because we really look for that when you're looking through proposals, as well as then saying clearly who will sustain the project. This will allow you to make a stronger proposal. And I would now like to hand over to Jeff Katz, also an EPICS IEEE committee member. Thank you.
Jeff, if you're talking, I think you might be on mute. Jeff, if you are, I don't think we can hear you. I think it looks like you're still on mute. You are on stage, so if you want to just unmute your line. Jeff, do you want to try one more time to unmute? I think we're just having a little bit of difficulty getting Jeff to connect. Just to move things forward while we get Jeff connected, we'll just move on to the next question. Joseph, I know one of the questions we were going to ask is the main innovation element that was included in your project and how you balance the innovation needs of the end users and what resources did you provide to the community. If you want to start talking about that, we will work to get Jeff connected.
Okay, thank you. Well, there are many such devices actually, and they can provide the information regarding the air pollution, I mean the PM particles. They are available on the internet, but you have to have the idea. You have to like to find this information, and young people, high school students, for example, do not spend too much time searching for the air pollution. They have other things in mind. So we decided to bring this information right in front of their eyes. So when they come to school, they can see the levels. They go outdoors, they can see the levels. So they start to think about the pollution and hopefully start to think about the environment and the pollution of the environment. Anyway, that is the kind of innovative, educative part in the education. They are learning that it could be important for their health. Of course, then the questions come, why? Why is this important? And we have also answers for them to know because of their health, and they can have health issues if they breathe this polluted air. So this is something in reverse. That is not something they show they need. So we are satisfying their need, but we are showing them what they should need to know, kind of as educators usually do. I would say that would be the main innovation part of it. And the community can benefit very much. For example, I recall a statement of a kindergarten teacher on television, just news after they announced that extreme pollution has been in Skopje. And she said, if we knew that the pollution is so high this morning, we would have not let children go out in the yard. So if they had such a device to know it locally at their kindergarten, they would know. So that is another benefit for the community that we can offer with these devices. That's it.
Thank you so much. Sorry, we're still having some technical difficulties to get Jeff to join. But Nabila, could you answer kind of a similar question, the main innovative element of your project, how you balance the innovation with the needs of the end users and the resources that you provided to your community for your project?
Okay, thank you, Ashley. So the innovative part of the project is the integration of AI and IoT into a simple system that can actually be used by pharma in rural areas. We use my Salak Smart Farming app. My Salak Farming app use IoT sensors to collect real-time data from the farm and combine that with AI to predict weather patterns, automatically count fruit fly, and support pest management decision. And yes, balancing innovation with the need of community was priority for us, so we made sure the app was simple and used the local language. We also changed some of our original technical ideas after getting feedback from the farmers, so the innovation was always shaped by what they actually needed. And for resource, we provide printed guides in the local language, held hands-on training session for them, and create user manual and tutorial videos for the farmers. We are also currently developing a chatbot to make it easier for farmers to ask questions and get quick answer when they face common issue in the field. So that's from me.
All right, can everyone hear me now? Okay, but am I on stage?
Hi, Jeff. Yes, you are on stage now. I asked the first two questions to both Joseph and Nabila, so you can ask the question for Anarga now.
Sure. Anarga, do you have the question about your project and how you dealt with the wearable devices? Because yours is a little more biological focused, and there have been a number of EPICS projects submitted with different kinds of wearables, both for visual and measuring body functions and so forth. So, do you have any advice for other people that are considering projects along that area?
Yeah, definitely. Thank you, Jeff. So I think one of the biggest advices I would give for a wearable project is just define your scope way beforehand when you're starting to apply for this grant, because as you know, things can break or things can happen with hardware, because hardware is one of the things that are very challenging to work with, and it takes a lot of time, and sometimes it's not feasible to work on everything with the 1 year that you get to work on this project. So I would suggest to define the scope of what your wearable device will do. So have clear guidelines. If you're working with different team members and some multidisciplinary team, you make sure you have communication with them, and just focus on easy things first that you know will get done and won't have any problems, and then you can also list some advanced things as well that you think you might be able to do it. But if you don't do it, it's fine, because one of the examples that I have is from our project. We initially wanted the device to go inside your ear, to be like a headphone form factor. That was our initial goal, but towards halfway towards the project, when we started working on it, we realized it's a very hard to put the device inside your ear and then capture the EEG signals and audio information as well from that location. So we had to pivot, and we pivoted to a design that goes around your ear instead of inside your ear. So that was one of the changes that we had to make in our device. So that's one of the things I'll tell most of the students or professionals who are applying to this grant is make sure if you're working on a wearable device, have proper standards, have proper goals, and start small, and then you can keep on building upon that wearable device towards the end, and focus on your end user, what they want to have in the device, and what features would be more beneficial to them in terms of like the deployment in a real world setting. Thank you.
Okay. I think next I'm supposed to give some quote unquote technology advice, even though I had to fight with our AirMeet software just to be able to talk to you. One of the things I'll suggest that Narga just kind of touched on, and that is what I'll call the battle between hardware and software. there's always a compromise between, oh, I can do it in software and we don't have to buy this expensive sensor. Then you have to know enough electrical engineering to connect your Arduino or Raspberry Pi to an external device, especially if you've created the external device. So if you're using one of those small microcomputers, make sure you've got computer science and electrical engineering people on. Another strong suggestion is if your Raspberry Pi or Arduino have an optional sensor kit, buy it. Because if you don't know enough about hardware sensor interfacing, you'll save a lot of time, even though those kits cost maybe half the price of the microcomputer board. It'll get you a long way faster, especially since they give you example code. My first undergraduate degree is electrical engineering, and something we always say is KISS, KISS, keep it simple, stupid. That's an international engineering term. I remember we once saw a project about sorting bottles for recycling, and the solution that was proposed was put in a camera, have AI recognize the bottle, and then see what size it is, which is an awfully tricky thing, especially if the bottle is in motion in the recycling machine. But if you thought about cutting a metal plate with holes the diameter of the different sized bottles and pass the bottle over each hole until the first one that fell through is the size of the bottle. All right. And sometimes that just reflects too many electrical and computer science people on the project and not having a mechanical engineer. All right. So that's an example of keeping your project simple, makes your project more robust, makes the whole effort easier. We've seen acoustic-based projects helping hearing people, and they were sorting things in different frequencies by comparing them by using AI to look at the waveforms. However, 150 years ago, someone invented a guy named Fourier in France created the algorithm called Fourier analytics, and there were algorithms for it in open source. It's not too complex a thing even to program yourself. And then you get the relative magnitude of all the frequency components, and then you turn AI loose to say, what can I determine from knowing the frequency components? So using mathematics from over 100 years ago gives you a straightforward solution to what audio spectrum is being heard by your microphone. Then you let AI work on the judgment part. So those are all some suggestions for some of you that are looking at projects. Research it, ask your professor, look for something similar on the market and see what they do. All of that's important. Another thing I'd like to, if I haven't exceeded my time, I don't see anything in the chat for Ashley to unplug me. Safety is very important. All right. Another way to say it is do no harm. So there have been several projects about automated wheelchairs to help elderly people get around a nursing or an old age home. Something like that really can put the patient's life in risk, even though that's not your intention. You're designing this project for the first time. Your software skills may not be at their peak yet. Something like that needs to have a big red emergency button on it so the user can hit a button and stop it. Somebody to say, for example, their wheelchair. Maybe your vision system is not sending it down a hallway, but is sending it through an open doorway, which it assumes is another hallway and really is a flight of stairs, and that could have a bad ending. All right. So never think that AI is smarter than the actual user of something. Have a panic button available. Anything that touches a person. We've seen projects about holding a temperature probe correctly on somebody's forehead to take a proper measurement, or applying a force for an automated system that did physical therapy. And that's great until you realize that most servo motors can exert enough torque on somebody's leg to hurt them. So again, that whoever's in that physical therapy device that's software controlled, they need to have a handheld panic button to say, whatever, something's wrong, stop this thing and then go on. Those are the things people tend not to think about, but can be disastrous when showing your ideas to your community partner. So those are a few technology things. I guess I see the slide change, so I think Pedro's going to take over now and give some resource information.
Thank you very much, Jeff and Kay, for interacting with our panelists. Now, I have another question for you, for all the three of you. Did you utilize any of the EPICS in IEEE resources when you were creating your applications? And if not, what are the things that you wish you had known before submitting your proposals? Let's go with Joseph.
Thank you. I see now there are resources like project management course, and which is free of charge. I didn't know there are some links for paid courses, but also there is one for free of charge. It is nice to visit that resource. I somehow didn't visit that resource. I didn't research for that. So I followed some internet courses or blogs from respectful people about project management, and especially about running a startup. You know, our project is making devices, producing devices, so it has similarities with running a startup. The other resources, I think these sessions also are resources, and I think I visited one before we applied for the project. Well, that was it about the resources, and probably there are more. I browsed the information regarding the previous projects, so this is a lot of wealth of information.
That's great. Also, for anyone that is planning to write a proposal, we really encourage you to go into the website and check all the information that we have there. We'll go over the resources a little bit later, but we have tons of material that you can use to really build up your proposal. So Nabila, did you use any of the resources available? Did you know about them?
Yes, okay. I did go through all the resource on the EPICS in IEEE website. I started by watching the training videos, which were really helpful in understanding what EPICS is looking for. Then I read the call for proposal carefully, probably twice or third time, just to make sure we didn't miss anything important. And I also took a look at the evaluation rubric to make sure the way we explain our idea really match what the committee were looking for. And yeah, for me, going through all of that really helped us shape the proposal. It gave us a clear structure and helped us communicate our idea.
And that's great. Yes, we as a committee, we have a very clear vision of what we want. So, and in all the materials, you have all the information, you have pretty much a cheat sheet, you know, on that rubric that you can use to actually write and focus and align your idea and your proposal with what EPICS initially looks for. So yes, we cannot encourage you enough to go and really read and understand and appropriate those concepts in. So Anardia, what about you?
Yeah, I feel the previous speakers have covered pretty much a lot of the things what I did as well. But for me, I think it was like 2 years ago now when I submitted the EPICS proposal. That was like my early stages of my PhD. I was starting to write a lot more grants and proposals since then. So, but since that being like one of the first proposals that I'd written, it felt a lot to me because there was so much sections and so a lot of details that I had to include. But it just takes a little bit of time and effort if you just brainstorm what you want to write. And of course, looking at the website, looking at the previous projects, what they proposed and how they proposed it, and the helpful tutorials and guides that's already present in the website helped. So it's just about sitting together and like combining all these information to the specific questions. And I like how the form has specific questions for each section, so you know what to put, where to put. So those are the things that I did to submitting a complete proposal for this.
That's perfect. Thank you, Narkia. And now let's go the opposite way. So we'll keep on you. So what advice would you give to students to help them through the application process? Like what was key in the project being successful? You can extend a little bit of what you were mentioning just now.
Yeah, I feel one of the key aspects would be to know what your solution that you're proposing is, and be very clear throughout that, and just add some background or helpful resources that you find somewhere to just support your work, or like why you're proposing the solution throughout the proposal. I think that was one of the main things. And another key aspect is finding a community partner as well. I think that was another thing that we spent some time on, finding the perfect community partner and collaborating with them, and then mentioning them into their into the proposal, how they fit in your deployment of the solution. So I think those were the two key aspects that you have to keep in mind when you prepare for the application process.
That's a great advice. Yes, working hand in hand with the NGO, let them know what you want, let them hear them and understand what they want, so you can actually align your solution with their actual need. That's key for this. Thank you, Nargis. Nabila, which advice would you give to students planning to apply?
Okay, yeah, it's actually similar what with the previous speaker said. My advice is to start with the community needs, take time to understand their problem, and make sure the solution truly align with what the community is facing. And also don't skip the EPICS in IEEE resource. I found them really helpful when writing the proposal. Uh, and once the project starts, consistent communication is the key. Keep the community involved, share the progress, and ask for their feedback, and be open to adapt to the solution based on what they need. So that's from me.
Thank you very much. Joseph.
Oh, this is the same, actually. Know what the problem is, even if the community does not directly request such help. But is in my case, the students do not look for the information, but give them the information, and then they will start to think about it. So the most important is to have an idea how to help the community. That is a real help, actually, to keep their health, if possible. And regarding the application, of course, as much resources as are available should be consulted. But one thing is very important, as I felt, to have an entrepreneur mindset, kind of, and apply all these things that an entrepreneur should do to apply for funding of a startup company. There are some similarities. Of course, there are differences, but regarding this mindset, yes, that is something that should keep you going on. And having good idea, that is something that is essential to you, you feel it inside of you, then it will make the text correct. That will come out in the text. Of course, you have to write what they want to write about, but the idea will come out.
Those are really great advices. Thank you very much. I'm going to add just a little bit, and it's in order for you to be able to understand the community and to have that good idea come up. That's something that an AI cannot come up with. So we have been, like, we understand that many of you may be considering using AI tools to support your proposal writing process, and that's good. If you use it for style correcting and elements like that, that's a great tool for that, especially for non-native English speakers. That really help us also having high quality written proposals. However, we are not looking for solutions entirely written by AI, proposed by AI, supposed by AI. We want your intelligence, your contact with the community, your understanding of the community shown and put into the process, into the proposal. Do not do the shortcut. Go the good way, not the easy way. So please take that into account. So going on the next option. So our next call is May 1st. You still have time. You have less than a month, but if you really put your mind into it, you could do it. If you want to get all the details, of course, you can go into our website, epics.ieee.org. So this is a just the very details on this. Every project must have a nonprofit community partner and have the IEEE members involved. Also, this nonprofit needs to guarantee or at least certify that the solution will keep being sustained and working even after the project is gone, managed by them. So you need to transfer all the technology and all the knowledge into the NGO, the nonprofit organization. So we're looking for IEEE sections, chapters, affinity groups, even capstone project courses. You know, if you have that idea, please go in. We already mentioned our pillars: environment, education, and STEM outreach, access and abilities, and human services. And you can apply up to $10,000, which of course, you know, that includes pretty much material, some logistics. It doesn't include any fees, any honoraries for anyone. In addition to that, EPICS IEEE also can offer you opportunities for mentorship and resources to help you get into a successful results. We have 5 society partners, 5 IEEE technical society partners supporting this goal. So please also make sure that your proposal, if there's a way you can align with the technical requests from this society, you're more than welcome also to get in there. Next, please. And also, as we were mentioning, even as Nabila mentioned, we have this training courses for project proposal training. So you're going to get all the information firsthand from us, exactly what we're looking for to help you build that great proposal that we know that you can send in less than a month. Next, please. And of course, follow us. We have lots of way of communication. We have, of course, our resource page. We have news and articles. We have the past projects. All of that is on our website. Also follow us on social media, LinkedIn, Facebook, YouTube, in which you can see also like videos and stories of past projects that are that have been very successful. Some of them also here. So so please follow us. If you scan the QR code on the screen, then you can join our mailing list and have all the information firsthand. So if you have any questions, please you can write them on the chat function, and we will be more than happy to address them.
Pedro, there was one question, wasn't to a specific speaker, but I can read it out. How can we expand the reach of our local EPICS project to a broader audience nationally or internationally without compromising the specific needs and values of the original community? So I'm not sure if you want to tackle that, if one of our speakers want to tackle it, and we'll see if any other questions come through.
So I understand that you have already submitted a project, you have done a project and you want to expand it. Is that, if that's the idea, then we have several ways in here. First, if there's still ways in which you can improve it, if there's still some innovation elements, you can reapply. you can reply. We're working on how to keep supporting these successful programs that may have a phase two, that are thinking on improving it, on improving the initial design or scaling up. We could eventually help you on that, but there must be still a level of innovation, a level of design. Remember that this is a program that supports education through service to the community. So the main element is not only benefiting the community, but also encouraging or supporting learning. So that would be. If not, you can still contact us, and we can help you try perhaps find other ways inside of EEE, which has several programs available that could also help you follow up with this mission.
Okay, looks like we had one more question come in. Can we work with the government to implement our projects?
So government technically is not an NGO, of course it's a GO, but it would depend a lot on the project, how it benefits the community. It's like you can work partnering perhaps with we have supported projects that partner with the local government, like on the city council or public schools or organizations like that. But the project is directly benefiting a specific community for a specific need. So all I can tell you is it depends. It depends on the project, and it depends how the government is actually involved in this. So if you have already an idea of what you can propose, you can contact us, and we can definitely guide you towards if it will be eligible or not for the EPICS and IEEE program.
I may talk about my situation, if you allow. Yes, well, we cooperated with the high schools, but later we wanted to install a device at the primary school where there is a reference station from the government to do comparison of the data. And we had to apply to the municipality government for a permission to put that device. And they granted the permission, but also suggested to install another one at another school, so that not only the students will have, the pupils will have benefit, they will see what is going on, they will be educated, but also the government can follow by access to the data what is happening with the pollution, how is it moving through the municipality. And that is also double benefit, I think.
That's great, Joseph. Thank you very much. Yes, like you can, like the government, the local government can become a beneficiary of this. So also you could find another organization that would be the direct partner of the project, but also you can involve the local government in some of these matters. So I see a question from Mercy from Kenya. Mercy, it is imperative to have the organization before, because what we want is for the students not to create a solution for a problem that may not exist. So we want the students to address real problems from real communities, and we want an organization that will be able to indeed adopt that solution and keep it working in the long term. So coming up with a solution first and then looking for the organization is not feasible for this program.
Great, thank you so much. So it looks like we've come to the end of our time. Personally, I just want to thank the panelists and the EPICS and IEEE committee members who participated in our panel today. There is an email address on the screen. If your question was not answered, feel free to email us. And with that, I'll kick it over to Pedro for the final goodbye.
Well, again, thank you very much for joining us. Thank you, our panelists, Joseph, Nabila, Narkia, and to our committee members, Jeff and Kay, for being here. Please keep in touch with us. write great proposals. If probably May is too early, then we'll have our next call in October, which is also open for you if you need that much time. So keep working on advancing technology for the benefit of humanity, like our IEEE motto. So, well, there's a final question. Do we have time or?
You can answer that quickly if you want.
Okay, the question is from Asif. So if EPICS scores a proposal, then we would know what our proposal was standing. Usually we give feedback mostly for the projects that either were accepted or the projects that we still needed some more like adjustments. If you would like to have specific feedback, then you will have to write to us, and maybe we'll be able to give you some very small feedback on it. We receive a large number of projects, so giving like personalized feedback, it's a little bit complicated. But if you give us enough time, we may have the opportunity to give you that. So so thank you again all, and we hope to keep in touch with all of you. Have a great rest of the day, rest of week, and I hope you also participate in many other Education Week events.
Thank you.
Thanks, everyone. Have a good day.
Thank you, everyone. Have a good day.